Alright guys, I'm going to go through the second FRQ question that will potentially be on the test tomorrow. And this one has to do more with Taylor polynomials and building Taylor polynomials. So the function f has derivatives of all orders for all real numbers. It is known that f of 0 is equal to 2 and yada yada yada. So find the fourth derivative of f with respect to x. So here's the third derivative. We're going to find the fourth derivative. So the fourth derivative of x is going to be equal to, well, notice that this is a product. Oh, and this is a composition. So we're going to need like chain rule and product rule here. So let's start with the product rule because that's what dictates. Yeah. So the product rule says we're going to do the first term. So this is going to be negative 2x times by the derivative of this term. Oh, well, that's going to be times by the second derivative of f of x squared. Now I have to use a chain rule. So times by the derivative of the inside, so times by 2x. Okay, so plus, we got the first times the derivative of the second, that's what we have here, plus the derivative of the first, which would be minus 2, times by the second, f prime of x squared. And I don't think I care to simplify. If I can, I'm just going to leave it right like this right here. So let me double check though. So the first times the derivative of the second plus the derivative of the first times by the second. I think I'm good. Write the fourth degree Taylor polynomial about x equals 0. Okay, so a fourth degree Taylor polynomial requires that, well, first of all, a fourth degree Taylor polynomial, so I'm going to call it p sub 4 of x or something like that, is going to be equal to, so we need a sub 0. I'm going to write up here. So fourth degree Taylor polynomial should look like a sub 0 plus a sub 1 times by x, well, it's centered at 0, so it's just going to be a sub 1x. And then plus a sub 2 x squared plus a sub 3 x to the third plus a sub 4 and x to the fourth, where a sub 0, or sorry, a sub n, I guess I should say, so all of these coefficients are going to be equivalent to the nth derivative at 0 divided by n factorial. So for a sub 0, that's going to be equal to the 0th derivative at 0, and then in that case it's going to be 2. So this whole thing is going to be 2 divided by 0 factorial, and 0 factorial is 1. So basically my first term of my polynomial is 2. And then the next one's going to be plus 3x. Why 3? Well, this term right here, so a sub 1, is going to be the first derivative at 0 divided by 1 factorial. And the first derivative at 0 is 3. So 3 over 1 factorial is still 3 times by x. And there you go. Plus, man, my throat is really drying out. A sub 2, so the second derivative at 0. Well, we have the second derivative, but not at 0. So what is f double prime of 0? So f double prime of 0 is going to be equal to negative f of 0. And f of 0 is 2, so this is going to be equal to negative 2. Alright, so it's going to be plus negative 2 over 2 factorial times by x squared. Alright, so there you go. So we have a sub 2 right here. It's negative 2 because that's the second derivative at 0 over 2 factorial. There you go. And then we're going to need to use the third derivative too. So the third derivative at 0, the third derivative here is going to be 0. As soon as I plug in 0 here, everything else is going to be 0. So that's going to be 0. That means that we're not going to have a 0 x to the third is just going to be 0. So I'm not going to even write that. And then fourth, we need the fourth derivative at 0 divided by 4 factorial. So the fourth derivative at 0, since I did the fourth derivative here, I'm just going to plug in 0. So if I plug in 0 here, all that goes to 0. First times the derivative of the second. Yeah, all that just goes to 0. And then I plug in 0 here. So then that's going to become -2 times by f prime of 0. And f prime of 0 is 3. So -2 times 3. So this should be -6. So minus 6 over 4 factorial times by x to the 4th. You can simplify, although I don't think you need to. 2 plus 3x minus x squared, and then 6 over 4 factorial, 6 over 4 times 3 times 2, that cancels out, so it should just be plus 1 or minus 1/4 x to the 4th. All right, let's see how we did. I have the key pulled up here. So I can see it right here, 2 plus 3x minus x squared minus 1/4 x to the 4th. So this is worth 4 points. Big question. The first point is earned for correct fourth derivative. Okay. Second point is earned only for completely, correct expression for. Wait, what? Isn't that the first point? Oh, from form of product rule, I guess is what they want to see. So I think you basically get the first 2 points if you do the derivative correctly. That's what you get. Let's see. I'm gonna kind of have a polynomial that includes a response earns the first point but not the second point may evaluate the presented expression at x equals 0 and use the consistent non-zero value in computing the coefficient of x to the 4th and I don't know what that's saying, honestly. I don't care. I got it right. So a polynomial that includes a non-zero third degree term. Any term of degree greater than 4 or plus does not earn the 4th point. All right. I guess do it right and get all 4 points, which is what I do. You know what I'm talking about? Thing is, I don't even understand what these last 2 bullet points are saying. And I don't really care because I got it right. That's what you should take away from this video. I don't know. All right. For 6, the 4th degree Taylor polynomial for f about x equals 0 is used to approximate f of 0.1. Given that the 5th derivative of x is no greater than 15 on the interval from 0 to 0.5, use the Lagrange error bound to show that this approximation is within 1 over 10 to the 5th of the exact value of 0.1. So 4th degree Taylor polynomial for f about x equals 0. So yeah. So if we're using a 4th degree Taylor polynomial, then by the Lagrange error bound, the first unused term would be x to the 5th over 5 factorial times by, now in this case, we're not going to say the 5th derivative. We're going to say the absolute value of the maximum value of the 5th derivative at z. I guess one second, before I write this right here, I'm going to show that I'm talking about the error. So I'm going to say that the error has to be less than or equal to this expression, and I should plug in 0.1 for x, since that's what we're approximating. So that's what I'm going to do. So instead of writing x to the 5th, I'm going to write 0.1 to the 5th. Now, just so you guys know, 0.1 to the 5th is the same thing as 1 over 10 to the 5th. Okay, let's see right here. Now, I don't have z, but I do know that z is going to be somewhere between the center and between the value of approximation. Now, if that's where z is, I don't know how to find whatever this value is, but I do have a means of overestimating it. The maximum value of our fifth derivative of f is no greater than 15. So that's the maximum value. So this is going to be equal to 1 over 10 to the fifth times by 5 factorial times by 15. And now all that's left for me to do is to show that this expression is within 10 to the fifth. Well, here's the thing. 1 over 10 to the fifth, I'm just going to keep it actually as 1 over 10 to the fifth, times by 15 over, I'm going to just use some commutative law and move this over. Well, 5 factorial is 5 times by 4 times by 3 times by 2 times by 1. And that would cancel with the factors of 5 and 3. So this would be equal to 1 over 10 to the fifth times by 1 over 8. Now, this has to be less than 1 over 10 to the fifth. Because 1 over 10 to the fifth is equal, and if I multiply by 1 over 8, then this whole expression just gets a whole lot smaller. Well, not a whole lot, but it gets smaller. And so this is less than 1 over 10 to the fifth. So it has to be within 1 over 10 to the fifth. All right, let's see what we need to include, though. So this is 2 points. So the first point is earned for basically what I just wrote down. Subsequent errors in simplification will not earn the second point. So, yeah, what I had right there was perfect to use. Yeah. To earn the second point, a response must communicate the inequality is less than 1 over 10 to the fifth. A response that states that 15 over 5 factorial times by that or the error is equal to does not earn the second point. So essentially just stating that the error is equal to that does not earn the second point because it's technically not true. The error, we're not finding the error. We're finding an error bound. So by stating that the error is equal to this right here will not earn the second point. So stating that the error is less than or equal to this expression right here. If you want to use equal signs after this point, that's fine, because that's exactly what this is, but you have to keep in mind that this is only an error bound. It's less than or equal to, not equal to. So don't just say the error is equal to, because that is incorrect. You can use equal signs after you state the inequality first. All right, for 7, let g be a function. It says that g of 0 is equal to 4, and we got g prime of x is equal to this. Write a second degree Taylor polynomial about x equals 0. So a second degree Taylor polynomial is going to be equal to a sub 0 plus a sub 1 x plus a sub 2 x squared. All right, so a sub 0 is going to be equal to the 0th derivative divided by 0 factorial. So I'm going to say that it's going to p sub 2 of x. I don't know if I should be I'm going to say t sub 2 of x, since I use p sub 2 of x, I'm going to say t sub 2 of x should be equal to 4. I'm going to give myself some space, actually, because I'm going to do some work above that. Now I need to find the first coefficient. The first coefficient is going to be the first derivative at 0 divided by 1 factorial. So g prime of 0 is equal to e to the 0 times by f of 0. That's going to be equal to 1 times by 2. So it's going to be equal to 2, so it's going to be plus 2x. Now I do need the second derivative of x in order to calculate the second coefficient. And so that's going to be, I'm going to need the product rule. So the first times by the derivative of the second plus the derivative of the first times by the second. And then g double prime of 0, it's going to be equal to e to the 0 times by f prime of 0 plus e to the 0 times by f of 0. So that's going to be each of the zeros 1, but f prime of 0 is 3, and f of 0 is 2. So this is going to be 3 plus 2, which is going to be equal to 5. So plus 5 over 2 factorial times by x squared. This should be good enough, so let's go ahead and check what they have. 4 plus 2x plus 5 halves x squared. All right, so 3-point question. You do need to find the second derivative of x, the first two terms of a polynomial. So as long as you have, this earns the second point. So 4 plus 2x plus ax squared earns the second point with or without any supporting work for the first two terms. So that's cool. A response that earned neither the first nor the second point only earns the third point for a polynomial of the form given there where c does not equal 0, is declared to be g double prime of 0. Okay, a present polynomial with no support of the coefficient of x squared does not earn the third point. And I guess there's some alternate solutions here, which honestly don't care to get into. So, okay, and that's going to be the second question. I'll do another video for the third.